So hello Greg, in this video I am going to tell you about the doubt which you have asked. You have asked me that in this amplifier you are not using any negative supply because you are using 0 to VCC. Still, how it is possible that we are getting a output which is on the both sides. So before that, let's have some discussion on the various aspects. So this is your operational amplifier. In operational amplifier, you can see there are two concepts. So one is called concept of virtual ground, while other is called concept of virtual short, concept of short circuit. So I'm not going into the details. So in virtual ground, if I ground it, then the voltage at this terminal will be zero. And if I apply some potential here, then this becomes short circuit. So if it is 5 volts, then this becomes 5 volts. So this concept is actually being used in the explanation. Other thing I would like to discuss with you is this operation, clamping and decoupling operation. So what we actually do, I will quote an example here. Suppose you want to cross a river, then what you do? You will have a, sorry, suppose you not a river, any road you want to travel from point A to point B. What you will do? You climb onto the horse, then at point B you deboard it. So, but horse is only meant for A to B. So similarly, this DC which we are using for clamping is actually meant for the points where we are actually applying on the operational amplifier and the output. So this is your V in of the operational amplifier. This is V out of the operational amplifier. So at the input, we actually clamp it, clamp the signal to VCC by 2. If we do not clamp, what happens? Only positive cycle of the your signal will be amplified, and it will be amplified from 0 to VCC. So it will not be amplified onto the negative cycle. Although this much amplification is not there, this is quite a big thing. Amplification will be there, but that is only for the positive cycle. So to make things possible, what we are actually doing, you are actually restricting the swing, because what is swing? Suppose you are having hanging chair at your home. What you are actually doing, you are putting it here in the middle of the room. So it will be swinging in the both the direction. So if you are putting your chair here somewhat, what happens? You will not be able to swing on the other side. So that is what we are doing with the signals. So we are actually making it at to the VCC by 2. So we are actually this level at the input so that our signal is clamped. Now after amplification, what we do, we are getting the output, and the output is not usable as it is because it is only on the positive side. So what we do, we declamp it, and when you declamp it, your signal is minus VCC by 2 to VCC by 2. So actually, your swing remains same. Suppose this is your 8 volts, this is your 4 volts. So overall swing is 8 volts. So similarly here 0 to 4 and 0 to minus 4. So overall swing is your V max minus V min. So overall swing is your 8 volts. So now we are using this concept in actual explanation of the circuit. So here you can see this is your capacitance. So only AC can enter the signal to the op amp. So your amplified signal enters here, only AC. Now we are putting a clamping signal here, VCC by 2. So this is the virtual short. So VCC2 will be available here. So at this point, what is your signal? VCC by 2 plus this. Both the signals are available. Now this is being amplified at this. So here your input is like this. This is your VCC by 2 and your input is like this. So it is being amplified here. So it is being amplified to the larger extent, but it is above the zero axis. So once we remove the DC from this, so all the DC will be eliminated and you end up with AC signal only. So this is the beauty of this particular circuit, that we can use a single supply for a AC amplification. The thing which we have actually used is clamping and decoupling clamping operation. And how we have clamped the signal? We have clamped the signal by providing a voltage to the non-inverting terminal. So I hope you understand the concept. And if you have any doubt in this regard, you can again email me so we can have a discussion on this anytime.